Okay, Assalamualaikum and welcome and good morning. So today we are still in week 5. So today today's class we have to continue with this last topic for topic chapter 1, and next week we will do topic chapter 2, okay? All right. So for topic chapter 1, this is our last topic, which is still on curvilinear motion. But today we're going to do cylindrical components, which is radial, the symbol R, and transverse, the symbol theta. Okay, radial and transverse. So previously, let's recap what we have learned. So previously, I have taught you about curvilinear motion, whereby there are three methods to solve this methods. Can you tell me the three methods that we have learned? What was the first method?
Motion of projectile.
Yes, motion of projectile. So this one is the free flight motion where we use the rectangular components. Now there are two other methods for curvilinear motion, which are the non-rectangular components. So this one is rectangular components. So for the non-rectangular components, what did we learn yesterday?
Normal
Normal
and
and
tangential.
Okay, normal and tangential. And then we have another one that we're going to learn today, which is
radial
Radial
and
and
transverse.
transverse.
okay, radial and transverse. Okay, so the key point in subject dynamics is that you understand the lesson plan, the topics, and when you get the exam questions, the tests, the assignments or whatever you assessment that you get, you have a look at what is required for you to do. You have to decide which is the best coordinate system to use. You have to decide, okay? Because in the question they will not tell you either you want to use motion or projectile, normal or tangential, and radial and transverse, okay, for curvilinear motion. So it's your part where you decide which is the best method. And usually, once you are able to identify which is the best method, what I mean is the best coordinate system to solve that problem, inshallah, you are able to solve it and get good marks because you understand. Okay, students that get low marks is that when they get the question they don't know where to start, where to begin. That is what we want to prevent. Okay, if as long as you know, okay, this is normal and tangential, I can do this, I can try. Okay, first, for all these questions, the first thing that we have to do is set up the coordinate system. So if motion of projectile, you need to resolve the components to x and y direction. If normal and tangential, you need to write the coordinates for the normal n and the tangential t. And for the radius and transverse is the same. You have to write the coordinates for radial, which is r, and transverse, which is theta. Okay, good. So as long you understand that, I believe whatever question is given to you, you are going to be able to try your very best and you can answer it. Okay. It's not like something that you get a question, you don't know where to begin. No, that is not dynamics. Okay. All right. Now, and the other thing, usually we try one tutorial question, but of course it's not good enough. You have to try multiple types of questions, then you will get the idea. Okay. All right. Now, so when we talk about radial and transverse, these are the components that are used for the motion of the particle that is constrained on the path. Okay, that is described using cylindrical coordinates. Okay, so therefore, when we talk about cylindrical coordinates, polar coordinates are used. The polar coordinates that I am referring to are radial r and transverse theta. Okay, so when we talk about polar coordinates, what we can do is we can specify the location of the particle using these coordinates, which is r and theta. So the coordinates which is r and theta is actually extend from a origin which is at point O here. Can you see? This is point O, origin. It is extend from an origin of point O. Okay, so later you will see the types of questions that are related to radial and transverse, and you will be able to identify. So the key point is the radial the coordinates, the radial coordinates, which is radial coordinates is what, r, r, okay, radial coordinates, which is r, is extend outside the origin from point O. Okay, as long as you understand that. And the transverse coordinate, which is, what is transverse coordinate? This one.
Theta.
Yes. The transverse, okay, this is radial. And let me write this. This is radial. This is transverse. Okay, so the key point is, okay, two things. I repeat, the radial coordinate is extend from outward from a fixed point O. So if you see, the radial is extend from origin from point O, and then the transverse coordinate is counterclockwise angle from a fixed reference line. So let's say our fixed reference line is this one, X. So sorry, no. Sorry. No, not that one. So our transverse coordinate is the counterclockwise angle between a fixed reference line and the r axis. Okay, so a fixed reference line, let's say this is our fixed reference line x and the r axis, so we have the transverse theta. So when you identify a question, oh okay, the radial is extend from an origin from point O, okay, and the transverse coordinate, which is theta, is a counterclockwise angle from a fixed reference line. So this is the fixed reference line x. So and then you have theta. So then you will know, okay, this is a question for radial and transverse. Okay, hold on. Someone is just entering our class. Okay. All right. Are you okay identifying R and radial and transverse? Is it okay? Can I proceed?
Yes, madam.
Okay, all right. Okay, don't worry. You will see similar questions and then you will understand, okay, this is radial and transverse, and you will see that it is not normal and tangential, okay? Because normal and tangential is something totally different, eh? Okay, all right. So those are two important points. Maybe I should write it down so that you will remember, okay? The radial coordinate R is R is extend outward from the origin O. Okay, from the origin O to the particle. Okay, this dot here is the particle, okay, and then the transverse coordinate, which is theta, is which is what you call the counterclockwise angle between a fixed reference line, and the r axis. Okay, so as you can see, this is it, and this is r. Okay, all right. Okay, let me highlight the one that I highlighting is the one in color purple. Okay, All right. So R is extend from the origin O to the particle. And then theta is the counterclockwise angle between a fixed reference line. So let's say our fixed reference line is X and the R axis. Okay, that is R, that is theta. Okay, this is two important points. If you are able to identify the R and theta, then only you can continue to understand better. Okay, but if you get the question, you don't know R, how is theta, is going to be difficult for you. Okay. So the angle, our angle theta is usually measured in usually measured in degrees or radian. Okay. Okay. So 1 radian equals to how many? 1 radian equals to what? 1 radian equals to 180 divided by pi. So let's say I give you 30 degrees. What is the radian? How do you calculate the radian? Can someone answer me? Let's say I give you 30 degrees. How do you calculate the radian? Conversion. How do you calculate the radian? Who wants to answer?
Times pi over 180.
So what do you get? You get 0.523 radian. Okay, so this is very important also, that you know how to convert. So if you get 30 degrees, it means 30 times, you need to times pi divided 180 in order to get your answer in radian. Okay, all right. So you must understand, when we're talking about radial and transverse, our transverse our theta should coordinate should be in radian. Okay, all right. Okay. Oops. Okay. Okay. Are you okay now? Now you understand what is R, what is theta, and you understand theta has to be changed in radians. Okay. Right. Now, okay. So what you can see in the diagram here, if you can see, the positive direction of R and theta coordinates can also be defined in unit vectors. So as you can see, I have written the unit vectors. This is what you call unit vectors, which is UR and U theta. Okay. All right. So don't worry, guys. Listen to my the concept and fundamental of radial and transverse, and then we will start proceeding with one tutorial question. And then after that, I have given you one final exam question for you to copy. Did you get it in the Telegram?
Yes, madam.
Okay, so that is one example of a final exam question in 2019. Okay, all right. Okay, okay, okay. If you notice the UR, the unit vector UR, the direction of the unit vector of UR is increasing. Okay, okay, is increasing. It means this R can be extend, 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 and it will be increasing. Okay. Okay. Whereas U theta is the direction of the theta, whereby it will be the increasing theta. Okay. So the what you can see is UR is the direction of the increasing R, and U theta is the direction of the increasing theta. Okay. All right. So if you notice, UR and U theta, it is perpendicular to each other. You understand perpendicular?
Yes.
Okay, all right, okay. I know these terms are apa, quite difficult, but I'm trying my very best to explain to you. So whenever you get any kind of questions, you are able to illustrate it. Okay, all right. So don't worry. Dynamics is not difficult. I'm sure you can do this. Okay, all right. Now, okay, good. So you understand this. Okay. So here are some important formulas that I need you to take note. Okay. So some important formulas in this topic. Okay. So don't worry because the subject is what you call open book. These formulas you can copy and put it aside for you to whenever you get the questions that is related lah. So some important formulas for this topic radial and transverse. Okay, is okay. So copy these important formulas. Okay, so V equals to VR UR plus V theta U theta. Okay, and the other one is VR equals to R dot. Okay. And then V theta equals to R theta dot. Don't forget the dot. Okay. All right. And then other formula for acceleration, which is important, is acceleration is AR UR plus A theta U theta. Okay. And then AR equals to R double dot minus R theta dot squared. Okay. And then one more formula is A theta equals to R theta double dot plus 2 R theta and then 2 R dot and then theta dot. Okay, so these are the important formulas that you need to remember for this topic. Okay, all right, let's circle these important formulas. Okay, all right. Okay, now you must be wondering, oh, where these formulas come from, how it exists, and how did we come across these formulas? Okay, so the derivation for the formula is long to explain and difficult to explain, but at least I want to show you the derivation how this formula comes from. So if you want to understand more in detail, you can look for in the textbook for how the formula for these other derivation comes from, or just copy in one place and just remember. But however, for today's class, I just want to highlight the derivation, how the formula for this one comes from. At least you get an idea, or okay, you're not just memorizing formulas, you understand where it comes from. Okay, so a good example that I can give you is, let's say we have a satellite. Okay, this is an example of a radial and transverse. Okay, let's say I am drawing here a satellite dish. Okay, so a purpose of a satellite dish. So this is a satellite dish. Okay, so the purpose of this satellite dish is to track a moving object in the air. So let's say we have a moving object in the air. So basically, this satellite dish, what it does is going to detect the moving object. It can detect the distance, the velocity, and all the other parameters that we want to find. Okay, so as the object moves along this curved line, the satellite will continue to rotate and it will calculate the important variables that need to be identified. So let's say we have a reference point here, X like this. So what it does is, as the particle is moving along this curved line, the satellite will identify the distance r. Okay, as you can see, you will find r. As long as it's moving, it will detect what is the distance. Okay, and then so basically and then also it can also detect the angle. Okay, so as you can see from the reference point, the theta, as the particle is moving, what happened to the theta? The theta increases, right? Okay, so this is a an example. Okay, all right. Okay, so this is what you call the polar coordinate system. Okay, where r is the length of the line. This is r, where it represents the length of the line. And then theta is what? The angle. The angle to measure uh, to measure the position of the particle, to measure the position of the particle. Okay, all right. Okay, so this is just an example for you. So basically, what you see here, the satellite is moving, is detecting the path of the object moving along this curved line. So the object is moving, yeah, is moving. Okay, I'm drawing the particle, the object, maybe an aeroplane or anything, something like that. Okay, all right. So basically, what we usually do is, let's say the question they ask you to identify how fast does the object is moving. For example, basically you will use the basic formula for calculating velocity. If you remember, the formula for velocity is dx over dt I plus dy over dt j. Okay, so this is the basic formula. However, for this type of question, what we need to do is we need to change the velocity. What we want to do is basically we want to change to find the velocity, for example, in terms of radial and transverse. So this is our main goal. So basically, instead of using the normal velocity formula, what we want to do is we want to find the velocity, but in terms of radial and transverse. So if I give you an example of a circle, for example, let's say we have a circle here, and let's assume this particle is moving from point P to point P prime, for example. Okay, so this is the angle theta. So this is the change show. So this theta, this theta is the angular distance, and sorry, what am I saying? Sorry. And the difference is what we call the angle theta. Okay, this is the what you call the angular displacement. Okay, this is what you call the angular displacement. Okay, it means the change in position of theta. First it was at point P and then it turns to point prime. So usually when you want to calculate the distance, this one S, do you remember the formula of a circular, the distance of a circular? Do you remember? S equals to what? R? R times change in theta, or R theta. Okay, so usually this is the formula untuk for you to calculate the lilitan, right? So um basically basically you can calculate the distance of the particle from point P to P prime using this basic kinematic equation. This is actually the basic kinematic equation. So from this basic kinematic equation, let's say I divide it by the time, okay, because the change in particle from point P to P prime is due to the change in time. So let's say we divide it by time. So ds over dt is what you call v, and then r, and then d theta over dt is what you call theta dot. So as you can see, is this formula very familiar to you? Something that you just copied just now?
Yes, madam.
Ada nampak kan? Okay. So this is the formula that you just copied just now. Okay. All right. I know you must there are a lot of formulas above here. However, it's not going to be easy for me to explain the derivation of all these formula. But for this class, at least I want you to understand that okay, V equals to R theta dot comes from here. Okay. I don't want you to be one of those students that just say the lecturer never explains the derivation, the process, and just ask to memorize the formula. But however, for this topic, for this class, I'm just showing you for one formula. Okay, so at least okay, you get it, you understand. And then for future other formulas here, what you can do, you can open your textbook or you can open your slide notes. There is an explanation how the formula comes from, but at least you understand. Okay, here velocity is equals to r theta dot, how it came from this basic kinematic formula. So basically all this actually comes from the basic kinematic formula. Okay, all right, so good. Okay, so that is the concept and fundamental that you need to understand on topic radial and transverse. Okay, good. Now, any questions before I want you to look at the tutorial? Any questions on radial and transverse? This is just the concept and fundamental theory only. We haven't started doing a question yet. Any questions before we begin? Any questions? No. Are you all awake?
Yes.
Please be awake, eh? Okay. Today I'm going to try a slightly different technique. Okay. I have actually prepared already a video on this topic and the example. Okay. All right. Now, I'm going to share my screen. Okay. Can you see this?
Yes, madam.
Yes, madam.
Okay. All right. Okay. You can see this screen. Okay. I'm going to share you this video link. Okay. However, I want you to look at minute 34:49 only. Can you see this example? Uh, a hydraulic cylinder. Okay, let me just read the question for you. As the hydraulic cylinder rotates around point O, so this is a hydraulic cylinder, it rotates about point O. The exposed length L of the piston rod P is controlled by the action of the oil pressure. So it means this uh, piston, what it can do, the R, it can increase, can decrease, increase, decrease. Okay. Now, so if the cylinder rotates at a constant rate of theta equals to 60 per second, and L is increasing at a constant rate of 150 millimeter per second, calculate the magnitude of velocity and acceleration of B when L equals to 125. So you can see that particle B. So it's asking you to calculate the asking you to calculate what is the velocity and what is the acceleration. So as I explained to you, basically for topic dynamics, they will always ask the same thing: find the acceleration, find the velocity. But how you find the values using what method depends. So this question, I have done a tutorial on it. Have explained very clearly how to do it. I want you to look at the video. So the video duration is not long. Let's say how many? I think less than 15 minutes, I think. So have a look at this 15 minutes video, copy the question, and follow the instruction and understand it. And then after that, okay, after this, you look at this tutorial video. What we're going to do is we're going to look at this. Um, sorry. I did give you a question in Telegram. This one. Okay. This question. Can you see my screen? Hello?
Yes, the
Okay. Now, for this question, it looks very similar to that question. However, it's slightly different. The values are different. But if you can understand that tutorial question, you are able to answer this question. Okay, so this is what I want to test. I want to see whether you looking at my video works, and after that, you are able to answer this question correctly. Okay, this question is a question example from the final exam question. So when you look at this question, you already know, oh, this is confirm radial and transverse. Okay, how do you know this question is from is a radial and transverse? How do you know?
Have
Because you
angle.
because there's the angle theta, and then there's r, and also what else? You know, you can see that the location of point B is what? Extend from what? Extend outwards from the origin O, right? Am I right? And you can see that the theta, the coordinate, is counterclockwise angle from a fixed reference point. So when you see this question, you say, oh, this is radial and transverse. Anyway, in the question, they already told you, determine the radial and transverse. Okay, so what I want you to do is, number one, I want you to look at this video, but look at minute what? 34:49. Okay, this video at the beginning is all other topics. I don't want you to look at the other topics. I want you to look at what minute? Let's say 34 at minute 34. So I'm going to share you this link video to your Telegram right now. I will give you around 15 minutes to look at the video. Okay. All right. Okay, did you get the video? Okay. Look at minute 34, 34 minutes and 45 seconds. And then after that, so I give you around 15 to 20 minutes to look at this video and copy the solution. And after that, we can go through this final exam question. Okay. Is my instruction clear enough? Yes?
yes.
Okay. All right. Okay. Please don't sleep looking at my video, and then waiting for me to discuss this. Okay. All right. Okay. So I will be so what we you can either stop joining. I will give you 20 minutes. However, I will not off this Google Meet. You can either leave and then or come back, but come back in another 20 minutes. So I will call you back around 9:30. Okay.
Okay,
So
madam.
join back at 9:30 a.m. And then what I will do is I will call randomly one or five of you to show me that you have copied this tutorial. Okay? Is that fine? Anybody having do not understand my instruction? Faham. Okay, good. All right. So I will come back to you at 9:30. Okay? You can leave this you can leave this Google Meet and join back at 9:30. Okay? Alright.
Madam, nak tengok yang nota tadi, madam. Yang
Nota
bulannya
tadi. Okay, boleh? Which part?
bawah tu.
Bawah. Okay. Okay. Alright. Okay. Okay. Is that okay?
Okay, madam.
Okay. Alright. Oops, nota tadi. Okay. I think I want to call your attendance lah. I want to see who's online. Oh, but some of you have.
Okay, madam. Thank you, madam.
Okay, ada ke yang dah left? I don't know lah whether you have left. It's okay. I will call you back at 9:30. Okay, so you have 20 minutes to look at that video and then tell me what you have learned from the video. Okay, all right. Whatever it is, I'm here. Okay, just call me lah if you need anything. In case you buzz me, you can send you need something, you can send a message to chat or through Telegram, and I will respond as soon as possible. Okay, some of you have sent me your solution for some tutorial and tests. Today I have full class, however I have looked at it and I will comment and give feedback for those who have send me the solution. Okay, thank you for those who did the solution. Okay.